Okay, parallelograms. It's going to look at some basically different properties of parallelograms and also solving some problems using parallelograms. So, what is a parallelogram? Well, it is a quadrilateral with two pairs of parallel sides. So if I've got a quadrilateral, and as you can see here, I've got this, TI is parallel to ME, and TE is parallel to IM. It's basic definition of it, which means kind of like looking at what the different properties are, that if a quadrilateral is a parallelogram, then it has two pairs of parallel sides. That's the first basic property. Second property is that if a quadrilateral is a parallelogram, then opposite sides are congruent. Okay, this is a very important property. We're going to use this over and over and over and over again. So again, if I have a parallelogram here, then KI is congruent to NG, and GK is congruent to IN. All right. Next property is that if a quadrilateral is a parallelogram, then opposite angles are congruent. So angle K is congruent to angle N, angle O is congruent to angle G. So again, if one of them is, if angle K is 110, then angle N is 110, etc. Next property is if a quadrilateral is a parallelogram, then consecutive angles are supplementary, which means that, so again, angle 1 plus angle 2 is 180, angle 2 plus angle 3 is 180, angle 3 plus angle 4 is 180, angle 4 plus angle 1 is 180. Now this, you should be able to remember this. This comes directly from the same side interior angles theorem we had back when we looked at the parallel lines, because you've got, again, this and this are both interior angles, same side. These two are both interior angles, same side, that whole thing. And then kind of last property here is that if a quadrilateral is a parallelogram, then its diagonals bisect each other. That means that this diagonal and this diagonal cut each other in half. So the pieces we've got, so this piece is congruent to this piece is congruent to this piece. Okay? So looking at some problems here. I've got a parallelogram. So we assume that if it looks like a parallelogram, it's a parallelogram, at least for this purposes. So I've got a parallelogram here, and again, what I know is that opposite sides are congruent. So if this is a parallelogram, then this side is congruent to this side, which means that's what my equation looks like. So 5x plus 3 equals 2x plus 15. Cancel off, get my variable on one side, my numbers on the other side, and I get x is equal to 4. So on number 2, this is looking at the idea that opposite angles are congruent. So I know this angle is congruent to this angle. So again, that's how I set up my equation, which means that x is going to be 42. And then on number 3, I know that my consecutive angles, or angles that are next to each other, are going to add up to 180. So I know that if x is 42, then 3 times 42 is going to be 126. Subtract that from 180, and I get 54. Okay, so now we're going to look at what are called special parallelograms. These are parallelograms that have particular unique properties. So the first one of those is a rectangle. Now again, you've been hearing about rectangles since you were probably in elementary school. But we're going to define a rectangle as a parallelogram with 4 right angles. Okay. Now one of the properties that if a parallelogram is a rectangle, then its diagonals are congruent, which means that so FS is congruent to IH. And if you do any kind of like carpentry work, or if you do any kind of construction work, sometimes you might hear something called checking for square. And that's a process by which, let's say you're building a box and you want to make sure that you've got all of your angles are right angles. So if you know all of your sides that are the right sizes. So what you'll do is you'll measure diagonally. So if one diagonal is the same length as the other diagonal, then you know you've got right angles. That's how that's used. Okay. Now, because a rectangle is a parallelogram, it also inherits all the other properties of parallelograms. So it also has the opposite sides parallel, opposite sides are congruent, opposite angles congruent. Actually, all of the angles are congruent because they're all right angles. which means that they're also all supplementary, and that the diagonals bisect each other. So that not only are the diagonals congruent, but they also bisect each other. Okay. So let's look at some problems with this. So LW, well, we know that opposite sides are congruent. So opposite LW is FO. FO is 30. So that's what my LW is going to be. Okay. OL, now OL is a diagonal, but it's also going to be the same as FW. Well, FW is going to be double what the 17 is here, and so you're going to have my FW is going to be 34, so LL is going to be 34. And then finally I've got OW. Now OW is this side right here. I don't really know much about that, but I do know that I have a right triangle. So I can take OW squared plus LW squared is equal to OL squared. We've already said that LW is 30, and we already know that OL is 34, so I get this sort of equation. So squaring everything, I get O squared is going to be 256, which means that OW is going to be 16. Now, you could also might happen to recognize this as one of the Pythagorean triples I talked about, which was as an 8, 15, 17 doubled. So, if you didn't notice it, that's okay. I just wanted to point that out to you. Okay, rhombuses. Rhombuses, you can either say rhombus or rhombi. I've used either one as a plural, whichever way to go with that. Essentially, it's a parallelogram with 4 congruent sides. One way I like to kind of describe it as a square that got drunk, because the angles are not right angles, but it's basically got all the sides the same, just like we think of with a square. Now, one of its properties that it has is that if a parallelogram is a rhombus, then the diagonals are perpendicular, meaning they're going to form right angles. Okay, so this diagonal and this diagonal form right angles to each other. And just to kind of give you a quick little proof of this, this is just so you know why this is true. Okay, so I know because it's a rhombus that this side, BO and OW, are the same length. Okay, so these two sides are the same. I also know that the diagonals bisect each other because, again, it's a parallelogram. So BS is congruent to WS. And then going back to our reflexive property, OS is congruent to itself. And so I have a side, and a side. So these two triangles, this triangle here and this triangle here, are congruent to each other. Now, because they're congruent, remember CPCTC says that the corresponding angles are congruent, which means that this angle is congruent to this angle. The only way that works, because they also are a linear pair, is that if each angle is 90 degrees. So that gives me that my diagonals are perpendicular. Okay. Anyway, so if a diagonal is a rhombus, and then related to the whole side thing, then each diagonal bisects a pair of opposite angles. So angle 1 is congruent to angle 2, angle 3 is congruent to angle 4, angle 5 is congruent to angle 6, angle 7 is congruent to angle 8. Well, since opposite angles are also congruent, then you've got angle 1 congruent to angle 2, congruent to angle 5, congruent to angle 6, and 3 and 4 and 7 and 8 are also all the same. So that's kind of how that works with a rhombus. Okay, so looking at a few problems here. So if I have a rhombus whose perimeter is 7, I have a rhombus whose side length is 7, what is the perimeter? Okay, so the perimeter is going to be 4 times 7, which is going to be 28. Okay, so given this rhombus here, I want to find the value of x. I know the perimeter is 40, which means that each side is going to be 10. And I know that this piece here is going to be 8. So thinking back to my triples, that means that x is going to be 6. Okay, or if you want to do it, you can say x squared plus 8 squared is equal to 10 squared and work it all out that way. All right, then we've got finding the value of y. because it's a rhombus, this angle and this angle are the same. So I set it up my equation that way, which means that I have 10y is equal to 20, or y is going to be equal to 2. And then finally we have a square. Now a square is basically the rectangle and the rhombus got married, had a baby, and it was a square. It has all the properties of a rectangle and all the properties of a rhombus. So all the diagonals are congruent, all the diagonals are perpendicular, diagonals bisect opposite angles, all that good stuff.